Okay, so now we want to look at example 2, and that's talking about the sampling variability. And this is the type of stuff that I really like looking at. So how does it vary? How does the distributions vary? So what do you think would happen to the sampling distribution if everyone in the class took a random sample of 40 beans? Remember, it was 20. Okay, so this changed here. We went from 20 to it's now 40. Okay, remember at the bottom of that graph where it said n equals 20? At that standard of that number line, well, now it's going to be n equals 40, because that's the number in the sample. Okay. To help answer this question, you will repeat the process described in example 1, but this time you will draw a random sample of 40 beans instead of 20. Take a random sample of 40 beans with replacement of 40 beans. So take one out, mark it, put it in there, mix it up, and take it again. Count the number of black beans in the sample of 40. Now, I want you to think, well, let's just keep going. Answers will vary, but the number of black beans will center around 16. Well, why is that? What's 16 out of 40? And that's going to be, again, that's equal to 40%. And it should be. Okay? What was the proportion of the black beans in your, well, we said it was around 40, again, okay, around 40. So, write your sample proportion on a sticky note. Now we're going to do the same thing. We're going to make the chart. And now look what happens. Okay, notice right here, we've got a sample of 40 instead of 20. Remember, we did have some down here at 0.15 and over here at 0.1 or 0.65. But notice what's happening. Everything is squeezed in. Okay? And the reason why is because this is a proportion. Okay? These are proportions. So, here's what you need to take away. Big time. Get this in your head, because you will see this for the remainder of this semester. As your sample size increases, as the sample size increases, the variability decreases. Okay? As the sample increases, variability decreases, which means it's not as varied as much, right? It doesn't go all the way to these other ones. Okay? And if you'll think about that, if now you're taking a sample of 40, next you take a sample of 80. So let's think about it like this. If the school, the entire school, there's 100 kids. Let's just say there's 100 kids in the entire school. Well, if we sample 20 of them, that'd be 20%. Okay? Is that as good of a representation as it would be if we surveyed 50 of them? No. Okay? It's not. So, the more accurate you're getting with the more sample size, your variability is going to get smaller because you're getting more accurate in your proportions. Okay? So they should be centering around your 0.4. Okay? Should center around it. Now, let's go to page 5 or page 6. Sorry. So it says describe the distribution. Well, it's still going to be mound shaped, right? The distribution was still mound shaped. Okay? But the tails over here are a lot smaller. Okay? Now, it says what is the smallest sample proportion? What is the largest? And then, of course, which one occurred the most? Well, here, the last time it was 0.15. Here's 0.55. The last time it was 0.65. Now notice that this remained the same. They were around the 0.4. Okay? Notice it right here. Now, it's not the most, but that's where it's centered around. Okay? You're not going to get this exact every time. But whenever you're seeing things like this, where there's huge mounds on one side and the other, then it should be centered around that right there. That's how you know 0.440 is the center. Okay? Thanks for all that. Now, using technology, find the mean standard deviation and the sample proportions used in constructing the distribution created in the class. Okay? So once again, you just go type all that into Desmos, or Desmos, whatever you want to call it, and it will give you those answers. Notice that the mean will still be around 0.4, and look, this is dropped. Standard deviation was, I think, 0.11 on the last, or 0.12, I think is what it was. Let's see if it's brought up here. 0.13 almost. So, the last time it was 0.13. Now it's 0.08, which means that it's not varied as much. The closer to 0 you get means there's less variability. And that's what we want, because that means we're getting more accurate. So how does the mean of the sampling distribution compare with the population proportion of 40 hundredths? Well, the two values should be about the same, because sampling distribution of sample proportions is should be equal to the population proportion. Should be. You need to know that as well. You need to definitely know that as sampling size increases, variability decreases. You also need to know that sampling distributions of sample proportions should be equal to the population proportion. How does the mean of the sampling distribution based on size of 20 compared to the mean of the sampling? Well, it should be the same, right? The means of 20 and the means of 40, if they are true representations of the population, whether we're pulling 20 or whether we're pulling 40, the mean will stay the same. Now, as the sample size increases from 20 to 40, describe what happened to the sampling variability, or the standard deviation of the distribution of the sample proportions. Well, it got smaller, it decreased. Okay? The standard deviation of the distribution of the sample proportions based on the sample size of 40 is less than the sample size of 20. Standard deviation gets smaller. As sample size increases, standard deviations decrease. What do you think would happen to the variability, standard deviation, of the distribution of the sample proportions? The sample size of each sample was 80 instead of 40. So instead of n equals 40, now we're going to have n equals 80. What's going to happen? Well, it should get smaller. It should decrease. Okay? It should decrease if you have a sample size of 80. Because sample size goes up, standard deviation or variability goes down. Now, says the sampling distribution of the sample proportion can be approximated by a graph of sample proportions for many different random samples. The mean of the sampling distribution of the sample proportions will be approximately equal to the value of the population proportion. As the sample size increases, the sampling variability in the sample proportions decrease. In other words, the standard deviation of the sampling distribution of the sample proportion decreases. As sample size increases, sample proportions, distributions will decrease. The sampling distribution will decrease. Okay?